All right, let's do a lesson on solving rational equations. Suppose we want to solve the equation x minus 2 over x minus 3 equals 0. Well, what we want to do right away is determine any restrictions on x. In this case, since the denominator can't equal 0, we see that x can't equal 3. So we're going to multiply both sides of the equation by x minus 3, and we end up with the simple statement x minus 2 equals 0. Therefore, x is 2. But we have to compare that with the restriction. We have to make sure any answer we get in a rational expression equation doesn't conflict with a restriction. Theoretically, if our restriction had been that x cannot equal 2, then our answer of x equals 2 would not be valid. But the only restriction was x can't equal 3, so our answer does not conflict with that, so we have a valid solution. What if we want to solve the equation shown here? Well, what we can do is first state our restrictions. X cannot equal 4 and x cannot equal negative 2. We can multiply both sides by both x minus 4 and by x plus 2. And in doing that, we're able to eliminate these factors on the left-hand side and eliminate these factors on the right-hand side. And we end up simply with x plus 2 times x plus 3 equaling x minus 1 times x minus 4. Some people call that cross-multiplying. Now what we're going to do is expand and collect like terms. When we expand the left-hand side, we get x squared plus 5x plus 6, and expanding the right-hand side, we get x squared minus 5x plus 4. We can subtract x squared from both sides. Simply 5x plus 6 equals negative 5x plus 4, meaning 10x plus 2 is equal to 0. And solving that is pretty straightforward. We get x equaling negative 1 over 5. We have to make sure that that answer doesn't conflict with a restriction, but the restrictions were x cannot equal 4 and x cannot equal negative 2, so our answer is valid. Suppose we want to solve the equation shown here. Well, first thing we want to do is simplify if we can. We're going to factor the denominators. We get x plus 5 times x minus 2, and x plus 5 times x minus 3, and x minus 2. There's no harm in factoring the numerators as well. You know, some of you might say, hey, sir, why not call that 2 times 2x plus 1, and why not call that 2 times 5x plus 1? There's no harm in doing that, but it doesn't help us simplify either of those fractions, either of those rational expressions, so I don't really find it too helpful to do that. So we can state our restrictions. X cannot equal negative 5 or 2 or 3. Now, what we do after that is we look at these denominators. We look at all the factors. And I see that I've got a factor of x plus 5. Now that factor of x plus 5 is in the first denominator one time and the second denominator one time, and is not in the third denominator. I take the largest of those options. So since x plus 5 is in, looking at the three denominators separately, since x plus 5 is there one time and 0 times, I take the largest option of 1 and 0, which is 1. So my lowest common denominator is going to have x plus 5 to the exponent 1. Then I look at the x minus 2, and I say to myself, okay, that's in the first denominator one time. It's not in the second denominator. It's in the third denominator one time. So when I make my lowest common denominator, I'll choose the greatest of those, 1 or 0 or 1. The greatest of those is 1. And finally, I look at x minus 3. X minus 3 is not in the first denominator. It is in the second denominator one time. It's not in the third denominator. So 0 or 1 or 0, I take the greatest of those, and that's 1. So this is my lowest common denominator. It is possible in some questions to have a different exponent other than 1 on one of those linear factors. It doesn't happen in this case. So anyways, here's our lowest common denominator, and we can state the restrictions off of that. And we then write each of the rational expressions over the new lowest common denominator. So looking at this first rational expression right here, my original denominator was x plus 5 times x minus 2. Now we can say x plus 5 times x minus 2 times x minus 3. Well, we multiplied that numerator by x minus 3, so we're going to multiply this numerator by x minus 3 as well. Now look at the second rational expression, the one I'm circling. Our original denominator there was x plus 5 times x minus 3. Well, now it's x plus 5 times x minus 2 times x minus 3. We multiplied the denominator by x minus 2, so we're going to have to multiply our numerator by x minus 2, and we did. And finally, our last rational expression is simply 10 over x minus 2. Well, our new denominator will be x plus 5 times x minus 2 times x minus 3. So we're going to multiply, we've multiplied our denominator by x plus 5 and x minus 3. We have to multiply our numerator by x plus 5 and x minus 3, and that's what we get. Okay, so what we can now do is multiply every single one of these three expressions right down here in this equation. We've got three rational expressions, two on the left, one on the right. We're going to multiply every single one of them by x plus 5 times x minus 2 times x minus 3. And what that does is it eliminates all the denominators. We've now cleared out all those denominators because we've already said x cannot equal negative 5 or 2 or 3. We've now cleared all those out. We're not violating anything because we've previously stated our restrictions, and we can simply write out a long equation like that. Now that's the theory behind how you do it. I know that there are students who are able to just cut from once they factor it, once they do this line right here, they're able to just go directly from that line to the line shown without having to show all the denominators and without having to clear those denominators also. It's okay with me if you do it that way. Just know you have to know what your restrictions are, and the reason there are restrictions is because they came from denominators. Okay, so now that we've said all of that, all we're going to do is expand out the left-hand side and the right-hand side, and when we do that, we get this beautiful equation here. That's a quadratic equation, so we're going to set one side equal to 0, like that. Obviously, with a quadratic equation, we're going to want to factor. So we common factor out the 4, and then we have x squared minus 12x plus 35. We can then factor that to x minus 5 times x minus 7. That means x is equal to 5 or x is equal to 7. But not so fast. We have to double check that against our restrictions. Our restrictions are that x cannot equal negative 5 or 2 or 3. We did not violate any of those restrictions, so we can state this as our final answer. Our final answer is that x equals 5 or 7. Now, when you write this answer on a test, please don't do this. Please don't say x equals 5 or 7. X cannot equal negative 5 or 2 or 3. When you're asked a question and you're given an answer box, you're not asked for what x doesn't equal. You're asked for what x does equal. Just state what x equals. Don't include any of this other commentary. I will see that you did it earlier in the solution, so you don't have to put it in the answer box. All right. We'll do the word problems in a separate video. So hopefully that was educational.